using the steady state conditions. The steady state conditions, when we are doing the load flow, we are not considering that the values of the system are changing. So under the steady state, load flow study the steady state condition. So in case of the Ralphson method, we have the value of delta P, delta Q is equal to H and J and delta delta delta. So H is the derivative of H is the derivative of P with respect to delta, and N is the derivative of P with respect to B. J is the derivative of Q with respect to delta, and N is the derivative of Q with respect to B. Now the change in means delta, with the change in delta is affecting much on the change in P. Means the value of P is much affected if the delta is changing. So means if this derivative has a sufficient value, but the change in P on the change of voltage is decreasing very small. ये वैल्यू बहुत घट होगी, ये वाली वैल्यू है कि घट होगी। वोल्टेज का इफेक्ट जो रियल पावर से बहुत घट पैदा है चेंज इन वोल्टेज, ठीक है। सिमिलरली जो रिएक्टिव पावर के उपर जो डेल्टा एंगल है ਉਹਦਾ ਇਫੈਕਟ ਬਹੁਤ ਘੱਟ ਪੈਂਦਾ ਹੈਗਾ, ਪਰ ਵੋਲਟੇਜ ਦੇ ਉੱਪਰ ਜਿਹੜਾ ਹੈਗਾ ਤੁਹਾਡਾ V ਦਾ ਇਫੈਕਟ ਜਿਹੜਾ ਰਿਐਕਟਿਵ ਪਾਵਰ ਦੇ ਉੱਪਰ, ਕਿਉਂਕਿ ਜਿਹੜੀ ਆਪਾਂ ਕੰਪਨਸੇਸ਼ਨ ਕਰਦੇ ਹੈਗੇ ਕੈਪੈਸਿਟਰ ਲਗਾ ਕੇ ਕੰਪਨਸੇਟ ਕਰਦੇ ਉਹ ਵੋਲਟੇਜ ਨੂੰ ਇਫੈਕਟ ਕਰਦਾ ਹੁੰਦਾ ਨੇ। ਤੇ ਚੇਂਜ ਇਨ ਜਿਹੜਾ V is affecting the reactive power injection. So means we can neglect, if we neglect these two values, means we make these two values as 0, then this is known as decoupled load flow method. This is known as the decoupled load flow method. Means we need only a half calculations. In order to find the variables, we need only a half calculations. Another काम रहेगा, ठीक है। So now we have studied the your Ralphson method and Gauss-Seidel method. So there is a difference between the Ralphson method and the Gauss-Seidel method. In case of the Gauss-Seidel method, we are using the rectangular coordinates. We are using the rectangular coordinates, and in case of Ralphson method, we are using the polar coordinates. In case of the Gauss-Seidel method, the burden on per alteration, we are calculating the variables in the alteration. So calculation burden is less in case of the Gauss-Seidel method. But in case of the Ralphson method, in one alteration we are calculating the derivatives, we are taking the reverse. So the lot of calculations are going on. So means the calculation burden per alteration is more in case of the Ralphson method. Now in case of the Gauss-Seidel method, as the number of buses increases, the Gauss-Seidel method requires large number of iterations. But in case of the Ralphson method, the iterations not very much. It is almost the iterations remain the same. Also, as the number of buses increases, sometimes your Gauss-Seidel method fails to give the result, or it is not giving the accurate result. But the accuracy of the Ralphson method is not much affected by the number of buses. So these are the some of the difference between your Gauss-Seidel method and the Ralphson method. Sometimes in the examination you ask to get the difference. So means in case of the per alteration burden of the Ralphson is more, but the number of the alterations with the increase in the buses. When the system increases, we have a large number of the buses, we have 1,000 of the buses. Then the Gauss-Seidel method sometimes fails, or it is not giving the accurate results for the and also as the number of buses are increasing, it starts taking more and more time. And in case of Ralphson method, it's not very much with the time is increasing, when the number of buses is increasing, the calculations are more, time is increasing, but not so much as in case of a Gauss-Seidel method. So Gauss-Seidel method is a simple method, simple calculations, but the Ralphson method is the complex method. Okay? Lot of calculations, so you need to take a lot of mathematical operations are required in case of a Ralphson. So this is almost all about the load flow study. So next is your stability. So stability of the power system. So in case of power system, what we have the generator. Mainly the power is supplied by the generator, and we try to run our generator at the synchronous speed. Generator, in case of the generator, we have the magnetic field which we have excited, and also that magnetic field means the magnetic field is on the rotor. In case of a synchronous machine, you have supplied the magnetic field, you have excited the rotor, and your poles are on the rotor, and rotor is rotated with the help of some prime mover. Some prime mover is used to rotate the rotor. When the magnetic field is rotating, so we have the conductor on the stator, and some EMF is induced in the stator side, and when we make the connection, so your power starts going. But in case of the we have the interconnected system. Large number of the machines are interconnected with each other. So means all the machine must maintain the same quality level of the power. Same quality level of the power means the voltage level. When we are connecting the machines in parallel, the voltage of the machines must be same. Their phase sequence must be same. Their frequency must be same. So it must be maintained. So in case of the when you put more and more load, so it tries to slow down your rotor. So we need the more mechanical power. On the mechanical side, we need the more mechanical power, or we are getting now more electrical power. So due to this, when we increase load slowly we are increasing the load. So in that case, your prime mover also, your power required from the mechanical side is also, you need more mechanical power. So that will affect, we have the synchronous rotor field, rotor is rotating, rotor is a field. Also we have the field, synchronous field is induced in case of the stator. So our synchronous speed is always rotating at the synchronous speed. We have the synchronously rotated field. But our rotor can change its position. It is not lying with your synchronous axis. It is not lying with the synchronous axis. It can be ahead of the synchronous axis or behind the synchronous axis. Means the power which is delivered, the power which is transferred, that is equal to EV divided by X. The power which is transferred from one side to the other side. Let us suppose it is the V and it is the angle E. So here means the power, if a generator is supplying the power, we have some reactance X. And this transmission of power is given by E V divided by X sine of delta. And delta is the angle of the rotor. Delta is the angle of the rotor. So means if this angle is 0, means your rotor axis and the synchronous axis are simultaneously moving. Under that case, no power will be transferred. So in order to get the transferred power, we have some value of this delta. So when this delta starts increasing, when we get more and more power from the machine, delta starts increasing. But there is a limit for the delta. that when this delta becomes 90 degree, then your machine, your system can deliver the maximum power. Okay. So base we have the stability, power system stability is of the two power system stability is the many types of the stability. We have the voltage stability, we have the frequency stability, we have the angular stability. In case of the angular stability, we have the steady state stability, we have the transient stability, we have the dynamic stability. So these are the different types of the stability. So we will discuss the stability in the next class. We start the stability in the next class. Okay. So